Alrighty, and then we move on to section 6.2, applying properties of rational exponents. Now remember, these are the exact same properties that we saw back in chapter 5. We just give them new meaning when all of a sudden we have fractional exponents, but we use them the same way. So in problem number 8, when I have 8 to the 1/2 times 8 to the 5/2, I've got the same base for both, 8 and 8. So when I'm multiplying two numbers with the same base, I just add my exponent. So I have 8 to the 1/2 plus 5/2 is going to be 6/2. 6/2 is just 3. So I have 8 cubed. Now, if my power is 4 or less, that's usually a pretty good rule that we should evaluate it. So that means that 8 to the 3rd power, our final answer is 512. Number 9, same idea. We've got the same base, so we're going to add our exponents. 4 to the negative 2/3 plus 1/6, and that's something I'll do off to the side. Now you can either get your common denominator or you can zip, zap, zoom. If I zip, zap, zoom, I've got negative 12 plus 3 over 18. Negative 12 plus 3 is negative 9 over 18. That's negative 1/2. 4 to the negative 1/2, well, that's really just the square root of 4 to the negative 1st, which is the square root of 1 over 4, which is 1/2. Number 10, this time around we are going to subtract our exponents since we are dividing. So I have 5 to the 1/4 minus negative 2. Be careful about that. So it looks like we've got 5 to the 2 1/4, which we can write in improper fraction form. We have 9/4 as my exponent. So 5 to the 9/4 would be our final answer. And then number 11, there's two ways that we can go about this. We can either distribute that exponent first, but before I do that, I like to reduce inside my parentheses before I go about any other properties. So 2 over 2 to the 1/4, notice that I technically have 2 to the 1st over 2 to the 1/4. So I'm going to subtract my exponents because I'm dividing just like I was in 10. 1 minus 1/4 is 3/4. So I have 2 to the 3/4. Same deal with our x's. I take 2 minus 1, I have x to the 1st. Now that is still squared, so now I'm going to go ahead and distribute. When we distribute, remember that we multiply exponents. So 3 over 4 times 2 over 1, that's 6 over 4, which reduces to 3/2. 2 to the 3/2, x squared. From problems number 12 to 14, we are asked to simplify and keep an exact form. So we remind ourselves how to break radicals out of jail when we have square roots. And remember that if we don't see our index, it's an invisible 2. So I make my factor tree. I am looking for numbers that are perfect square values because the index of my radical. So I've got 1 and 75. 2 does not work. 3 and 25. This is good news because 25 is a perfect square. So then I can call this the square root of 3 times the square root of 25. And we do that because the square root of 25 is just 5. So I have 5, I've got a radical 3, and we know that we always write our whole numbers outside our radical numbers. 5, radical 3. For number 13, as I'm making my factor chart, I'm going to be looking for numbers that are perfect cubes. So I have 56. What numbers multiply to give me 56? I've got 1 and 56. I've got 2 and 28. I've got, does 3 work? 5 plus 6 is 11. No, 3 won't work. 4 and, let's see, 56 divided by 4, 14. 5 won't work, 6 won't work, but we've got 7 and 8. That's good news for us because 8 is a perfect cube. So I break the cubed root of 56 into the cubed root of 7 times the cubed root of 8. And I do that because the cubed root of 8 is 2, which I'll write in front of my cubed root of 7. Final answer. And from number 14, I am looking for numbers in my factor chart that are perfect to the 4th powers. So 343, what is divisible by that? I've got 1 and 343. It's not an even number, so I don't have 2. 343 divided by 3, I am going to get 81. That's good news to me because 81 is 3 to the 4th power. So I've got the 4th root of 3 times the 4th root of 81, and the 4th root of 81 is just 3. So then my final answer, I've got 3 times the 4th root of 3. And then we are asked to perform each of the root operations indicated below, and then be mindful of what operations are even allowed and when you need like radicals and when you don't. If we can't simplify it, we would just say so. So in number 15, if I have 2 root 2 plus the square root of 18, well, we would first want to break down the square root of 18. The square root of 18 can be broken into the square root of 2 times the square root of 9. And I do that because the square root of 9 is 3. So I have 3 radical 2 being added to 2 square root 2. Well, 2 radical 2's plus 3 radical 2's, altogether I have 5 times the square root of 2. Number 16, I've got 3 times the cubed root of 3 minus the cubed root of 24. Again, we want to break down 24, or the cubed root of 24, before we move on. 24's perfect factor would be 8. So we've got 3 and 8. So the cubed root of 24 is really the cubed root of 3 times the cubed root of 8, which, as we just said, was 2. So the 2 times, the cubed root of 3 is getting subtracted from 3 times the cubed root of 3. We do that subtraction. We do have like radicals, so we're able to do so. If I started with 3 cubed root of 3's and I took away 2 of them, I'd only be left with 1 times the cubed root of 3, which we often just write as cubed root of 3.